Hey guys, it's Mr. Bosher, and today we're going to start a new unit on something we call similarity. Similarity, I know. Still can't write with this thing, but I'm trying my best. And I'm hoping that this will be a pretty easy topic. Gonna try to make it a quick video, but we'll see how long the problem is. Alright, so let's keep it simple. First of all, what is similarity? It just means when two shades are almost congruent. Let's put it like that. So congruent was that they're the same shape and the same size. Similarity, we still want to have the same shape, but this time we have it in different sizes. Different sizes. Okay, so think of it, I can do it on the iPad right now. If I draw a triangle, that triangle is, maybe a centimeter big right now. But let's imagine I zoom in on the triangle, then it grows, right? If I zoom out on the triangle, then it shrinks. It's still the same shape no matter what, but I can change the size of that same shape, okay? That's what similarity is. You're taking the exact same object, but we're kind of growing it or shrinking it, and we're going to see what properties do we have. Well, the first property is that the angles, I should probably write this a little bit more specifically, but the corresponding angles are congruent, which makes sense. If I take this triangle that I drew over here, even if I zoom it in, the angle size is still the same, right? It's a bigger triangle than it is from over here, but the angle size doesn't matter. So the angles between similar objects will be the same as long as they are the corresponding angle, right? The same position on the shape angle. The second thing is corresponding sides are not congruent, because remember, if I grow this triangle, well, now the sides all have gone up in length. So they can't be the same length as a tiny triangle when I zoom out. So corresponding sides are what we call proportional. I'm not sure if I've used this word or what it specifically means with you guys yet. I know I've said it in a different class. But basically what it means is that we can set up a fraction, or specifically two fractions that are equal to each other. That's what it means to be proportional. So if I have like 10 over 2, and then maybe over here I get like 5 over 1. Those are technically the same number, but when I looked at it on the left side, they used numbers like 10 and 2, and on the right side I used 5 and 1. So pretend these are like the sides of the shape. Maybe like when I zoom out, it's side lengths of 5 and 1, but when I zoom in, it looks like it's side lengths of 10 and 2. We would say that the side lengths are proportional, okay? Because when I write them as fractions, they still come out to be the same number, but their numbers aren't exactly the same on what the side lengths are, okay? So if that didn't make that much sense to you, don't worry. Once we do problems, it should make more sense, but that's really the whole lesson. Can you spot if something is similar because it's the same shape but a different size? And then once you know they're similar, can you take advantage of the fact that the angles are the same and that the sides are proportional? So let me show you how we're going to do that. So let's move on from this. Let's go to some example problems here. All right. So starting off a little easy, and actually, that's kind of like my middle level one. So let me save that one. This is my very easy one. Let's start off right at the beginning of the assignment that I should have started for you guys tomorrow. And yeah, here we go. The first thing I want you to do at the very beginning is I want you to read this problem right here, which I know, crazy. I want you to read the problem. But the reason I want you to read the problem is that the order of the letters is very important, just like when we talked about corresponding parts with the congruent triangles, okay? And the reason for that is sometimes when they take these similar shapes, as they shown us here, they're going to maybe rotate them, right? They're going to spin them around, and it makes it a little bit harder to see what sides really match up. So if you want to avoid making a mistake because you match the wrong sides, just follow the order of the letters up here, okay? Also, as a little side note, if they do just one squiggly line, that means similar, okay? So they told you they're similar, and now we're going to take advantage of the fact that it says, well, AB should correspond to SR since they both start there. So I'm going to go ahead and mark that with the same color. So AB goes to SR. Then B and C should line up with R and T since they're the two last letters. So B and C lines up with RT, which means that my last side of AC lines up with ST, which makes sense because A and C is the beginning and end, S and T is the beginning and end, right? So that's what I want you to use the very beginning of the problem for, okay? Just kind of make sure you know what goes with what. If you can't use colors, which because you guys probably don't have as much options as I do on here, you could leave like little tally marks, like maybe red, you put like 1 on each, blue, you put 2 on each. Just be careful that you acknowledge that they're not congruent here, right? You're just making marks for yourself. You're not actually saying they're congruent. So I don't want you to get confused with that, but if you want to like mark a picture that you're drawing, that's an option. All right, so what do they want us to do? They want us to find this side length of ST. We don't know this. So how do we do that? Well, we're going to take advantage of that proportional property, which says you need 2 fractions. The way that I'm going to do this is I'm going to look at all the stuff that I have marked, and I want to pick a pair of sides that are the same color that I know the numbers for. So I'm looking at the green sides here. You could pick blue, but I just like the green ones more, personally. And all I'm going to do is I'm going to put them in the same fraction. So 39 was one length, 13 was another. Then on the other side of my fraction, I'm going to put the color that I am missing. So we want the red side length, right? Because that's the part that they asked for. Well, I know that on this triangle it was 30, and I used its other number of 39 on top of the fraction, so I'm going to write the 30 on top of the fraction again. Okay, essentially, the top parts of the fraction should come from the same triangle, or like the same shape, and the bottom parts should come from the same shape. Okay? Hopefully that makes sense. Which means that over here, I'm going to have x. Now, with similarity problems, you have 2 options. You can use the proportion, or some of you may have noticed, like, hey, 39 and 13, isn't this just saying, like, divide by 3? Right? 39 divided by 3 is 13. And if you notice that shortcut, you can take advantage of it, okay? Rather than doing all this cross-multiply nonsense to get x, you could just say, wait, if I notice that the side length is getting divided by 3, you can divide by 3 again, and this just comes out to be 10. Okay, and that's actually what I would recommend you do if you see an easy pattern like that. Okay, later on I'll show you a problem that's not as simple, where we will have to use cross multiply, so you get an example. But for these early ones, I would say that once you notice that you have an easy pattern, take advantage, and that way you don't have to set up this whole fraction. Okay, so final answer here should be 10, since 30 divided by 3 is 10, and I'm using that same pattern, or I saw that same pattern with the green. All right, hopefully that made sense. Now let me show you that angle problem. Let me bring up my writing tool here. Okay, so same start. First thing you want to do is you want to get the order of the letters. So HI goes with WT. So I mark HI with the same color as WT. I have IJ are the middle 2 letters. That's going to go with T and U. IJ goes with T and U. And then from here, since we have, we can just kind of follow the directions of the colors, right? So the next side length after green, I'm going to make red. So the side length after green over here, I'm going to make red. And I'll make the last one yellow, last one yellow. So as you see, they've rotated these shapes, so it makes it a little bit easier if you use this order at the top, so you make sure everything's matched up. All right, and then for this problem, they want you to find an angle, and we know that in similar figures, the angles are congruent. So I basically just have to find out, well, what goes to U? Well, U is the third letter, and J is the third letter. So if I look over here, J was an angle of 112. Since U is in the same spot in it, in the order of the letters, I know that it should also be 112. That's that whole problem. Okay, so the angle ones are a little bit easier, but that's essentially what you do. You just got to make sure you know what it matches to by taking advantage of the ordering of the letters at the top. Okay, so that's it. Measure of angle U would be 112, since we know that the angles have to be the same for their corresponding part. All right, lastly, let's do a harder version of the side length problem real fast, just so you can see why I told you about that cross multiply in the first place. So again, same beginnings. Look at the top, follow the order. So TU and DE go together. TU, DE go together. Then my next letters were UV and EF. So UV goes with EF. And then from here, you can just kind of follow the order of the shape. So next one will be yellow. Next one after green is yellow. After the yellow, I'm going to mark it with red. And then I guess we'll just use black for the last one. Okay? So now I know what goes with what. And they want me to find these three things: UV, TX, and WX. I'm not going to find all of them for you here because they're all going to kind of use the same process. You're just going to plug in different numbers. But I'll show you how to do one of them. Okay, so let's go for the first one, which is UV. Let's see. UV is green. So down here, I'm going to have a green fraction. And I don't know UV, so I'm going to mark that with an X. And the other green side is 49. So I'm going to put 49. Then, to pick your other fraction, remember you want to pick something that you know both sides for. So when I look at my whole picture, if I check blue, I have this 42, but I don't know the other blue side, so that's probably not a good choice for my second fraction here. Green, we already said, is in the problem because we're trying to find its missing value, so I shouldn't use it again. Yellow, I have two values for, so yellow would actually be a good choice. Red, I'm missing on this shape, so that wouldn't be good. And then black is missing on this shape, so that wouldn't be good. So it seems like yellow is our only good option for solving problems here since we know both of its sides. Remember that this X came from the shape on the left, so I'm going to use that shape's number to also go on top over here. And put the other number over here. Okay? And now that you have it set up, you just cross multiply and solve. So I'm going to say, how do I get X? I cross multiply. So I get 48 times 49 is equal to 56x. Once I do the cross multiply, I'm going to divide by 56 on both sides. And then with the power of Desmos, I can plug all of this in and get x equals something. And we'll get our answer here. So I'll do that real fast so you get an answer. And then I'll just show you how to set up like the other two so you know how to do your setups. So let's see. 48 times 49 divided by 56. Oops. Here we go. 48 times 49 is 2,352 divided by 56, we get 42. So if I go back over here, I could say my final answer should have been 42. Okay, And that's how you would solve for a side. Now, how would I do the other two? Well, my advice would be, we already know the two sides for yellow. So, there we go. We already know the two sides for yellow, so I would keep that fraction there. And then we would go to our next side, which is tx. So tx was the black. So then I'd write its two side lengths. So for black, I didn't know the number on the first shape, but I did know the number on the second shape, and I would set it up like that. Okay, your first fraction should always be the thing you know both numbers for. Your second fraction should have only one thing missing, and then you try to find that one thing. Okay, then for the third problem, same idea. Keep the yellow, since you know both of them already. And then for wx was the red. So I would write my two red numbers. The top would be x, since it was missing on that side. And then put 28 at the bottom, and I'd cross multiply. Okay? So hopefully all that made sense. Hopefully it seems pretty simple. And that's it. You either are setting up a proportion for your sides if you don't find an easy pattern like we did on the first problem, or you are just saying that the angles are the same and matching them up with the order of the letters. All right, so good luck, guys. If you have any questions, let me know. I'll see if I can fix them in the next video. But other than that, have a good day.